I am going to disturb you for few questions from previous week.
Yeah. First, let me go at this week's content, then we'll discuss questions.
Make it fast one because we have 1 hour now, because I have few important questions that we have to discuss.
Fine.
Few and very easy, not very tough. But I am not getting it.
Okay. Fine, then let me start. I was waiting for people to
Yeah,
join.
please.
Okay. Can you see my screen?
Yes, ma'am. Yes, ma'am.
So, in this week, like there are several topics on the applications or a variety of computer vision problems discussed. I will briefly go over this adversarial robustness problem. Yeah, so so we all know that neural networks are really well on solving a lot of computer vision problems, but then uh, can anyone fool the neural networks? If you ask that question, it turns out that they can easily be fooled. So here is one such example. So this is the actual image. It's an image of a panda, as you can see, and if the neural giving this image, the neural network is predicting it as panda with a confidence of say 57.7% here. If on adding this kind of noise, and this is not random noise, it's something specific. So if you add something like this in the image space, for visually we can't really make out any difference, right? It still looks like a panda to us, but then the neural network misclassifies it as gibbon with extremely high confidence. So this is called adversarial noise, and such samples are called adversarial samples. So basically these two images are visually look very similar, but in the uh, yeah. So if one can actually generate such noise in a conditioned way to add your images, and say you wants to make the model predict only a particular class or fool it. In such cases, this can it's possible to do that. So there are several methods that try to actually address this and make it robust against such attacks. So there are different ways in which these attacks are characterized as. One is based on what the attacker has access to. That is, so white box attacks are where the attacker has access to model's parameters. So we can can actually understand what the parameters are and try to generate adversarial samples. Another case is where called black box attacks, where the attacker does not have access to model's parameters. That's like only input and output I have access to, and the model is it's frozen, like I don't know what the weights are, nothing. uh, and another way of classifying is based on the objective of these attacks. That is, so untargeted attacks are where I only try to generate these adversarial images that make the model misclassify. I don't care what it misclassifies as, it only has to misclassify. So those are untargeted attacks. Targeted attacks are where say I want it to get misclassified into something specific, like I want to generate such images. So those are called as targeted attacks. And another way of characterizing these is based on the distance matrix. That is how far is my original image from the adversarial image generated. Like I use different ways of distance metrics to measure the distance between these two images in the image space, like using L0 norm, L0 norm, L2 norm, L infinity norm, etc. So, to mathematically stating this problem, so we have a true image, say, which we denote as x. Then its adversarial image x prime is one such that the outputs, like the predictions, that is f of x is not equal to f of x prime, and they are very close. So that is constrained by this epsilon. And different, like as I mentioned here, so this can be constrained based on different norms, as 0, 2 or infinity norms. So the way this the main idea of how to generate these adversarial images is that so in general what we try to do is, in our learning process, say we have the sample x and its corresponding label y. So its feature is basically, its prediction is f of x, which we wanted to match to y, right? So we minimize the loss with respect to that in general. Here, in order to generate that new sample, what we are trying to do is actually maximize the loss with respect to the perturbation. So here what we are optimizing is actually the perturbation vector, or in the image space, not the weights. So that is one main difference between this and the standard learning of weights. Like here the network is frozen, we have access to it, but then the network is frozen, and I am trying to optimize my input. So like if by what amount do I change the image, that is from x I want to go to x plus delta, such that I am maximizing this loss. So if I am maximizing this loss, then I am trying to make the model misclassify it, right? And that delta, the amount of perturbation, is constrained by some epsilon. So did you guys understand the problem? Any questions on the problem? Fine. Yeah, so there are several ways in which they try to estimate this perturbation. So these are some of these methods. One of the earliest methods: fast gradient sign method, projected gradient descent, universal adversarial attack, these things. So in fast gradient sign method, how it is optimized is that, so given my sample x, I try to move in the direction of ascent. Like, so this is my gradient with respect to x, and I will only consider whether so the sign of it just says in a particular dimension, should I so basically considering the positive gradient direction. So that's what this tries to do. And in projected gradient descent, what they do is, so here this whatever x prime is comes out as it is unconstrained, right? Like it can be yeah. So we are trying to make this as close as possible to x, but we still don't know where this x prime turns out to be. So in this projected gradient descent, they will project this x prime to back to a space constrained by this ball of epsilon. Like say from the point x, if I take a ball around it with radius epsilon. If suppose my x prime happens to fall outside that ball, then they project it back to the closest point inside that ball, so that it always satisfies this constraint. So that is called projected gradient descent. Yeah, so in all these cases, this is operated on each sample separately, right? So instead of that, if you want to compute one single perturbation, that is one delta that will attack on all the images. So I'm trying to learn here, the deltas are specific, it's specific to x. So that case is called as universal adversarial attack. Yeah, so these are some examples of so if this is my clean image, and these are the adversarial samples that are generated using different methods. So so like visually they are okay. In this case we can see some noise, but still we'll be able to classify what it is as, right? Like the image semantics are still preserved in all of these images, but then all of them actually misclassify, the model actually misclassifies all these adversarial images. Yeah, so these methods, this is a one-step process, this fast gradient sign. That is, I do this optimization only once, like once I update and I'm done. So these iterative methods are where you do repeatedly, continue doing it. Yeah, so these are basically, until now what we saw is how these adversarial images can be generated. Now suppose if I want to train my model such that it is robust against these kind of attacks. In such cases, if I actually incorporate such samples, like these in the training process, instead of only using my clean xi yi samples, if I start using xi plus delta and yi, which where this delta is optimized as we saw. So basically I'm trying to synthesize these adversarial samples, and over that I am training my network. So in such cases, because I'm trying to uh, so this adversarial attack is the test scenario, right, what we saw until now. So if I try to mimic that process during training and incorporate such samples, then in such cases the model will be robust against these adversarial attacks. Yeah, so here over different data sets, these plots show at the accuracy of the model when on training, including adversarial samples. So this epsilon shows the bound over yeah, this bound we are using, right? How much we want to deviate from the actual image to attack on it. So as expected, like if we increase epsilon, that's like I'm trying to like heavily attack the model or create very adverse samples, and incorporating such extremely bad samples will definitely reduce the accuracy, right? That's what you see here. I will go over the code for this fast gradient descent method. Just yeah.
Ma'am, last week's your problem solving session is not uploaded.
Yeah, I'll upload it today. Sorry.
Please, ma'am.
Yes.
Because I was searching here, there, everywhere, Google. I was doing all such searching, but I couldn't get it.
Yeah,
And I was, and that's because of that I couldn't get good marks, ma'am. Now, where can I get good marks for the week 11? Tell me, ma'am.
Last week didn't really discuss problems. There
Uh,
were
I only,
people didn't
I only,
attend class last week, so there were only
uh,
one or two members last week.
so ma'am, today I have attended, I have a lot of questions. Do not worry about it. But ma'am, I got 40. Now, sir, I score 80. Last week I scored 40. 40 marks lost, ma'am. It's huge, ma'am. I'm crying, ma'am.
No, you shouldn't.
I shouldn't. Ma'am, please help me, ma'am. I have a lot of questions also today. Okay, ma'am. Ma'am, leave the code part. Code we'll do with Abhipsa, ma'am. Let's start with the questions.
Questions of you want me to discuss this week's content?
This is content as well as a few previous week's content. Some few questions are there. I have numerical questions from week 1, few questions from week 2, few questions. Please discuss, ma'am. It's very urgent. And you can, ma'am, not a problem. You won't get you just give a hint and we will do it.
Fine.
Can we start? Shall we start, ma'am?
Yes.
Can I share the screen?
No, let me do it now.
Okay.
Can you all read this question?
Yes, yes, ma'am.
Yeah, so what does domain adaptation match to in this case?
Adaptation. Let me see them. Okay.
Any of you?
First will map to fourth. Source domain DS is used as additional data that may help learn better in target domain.
Yeah, right. So, yeah, in domain adaptation, we'll have access to one source domain which will have like labeled data, and like I have x and y both, and the target domain I have only the samples without labels. So using the supervision from source, and though there is a domain shift, like by domain shift, it's something like, say, I have collected only images during the daytime, and my target, so this can be something like daytime images, and this is nighttime images. So what is trained, if you train simply over daytime images and try to put that model for deployment in nighttime images, it will do somewhat reasonably, but then not the best, like it will not do as good as training over nighttime images. So using the supervision from this source data, and like this two domains are aligned such that you can't really differentiate between the two domains. In such cases, like the source performance is somewhat translated to the target performance, like because you're aligning the two domains. So that's what is done in adaptation. And what does domain generalization map to? Any of them, continual learning, k-short learning. So domain generalization
took a fifth, learn to perform well on previously unseen data.
Correct. So it's like when I'm training, I have access to some domains, but then when testing, the data can come from totally from an unseen domain, and but I have to train such that it can generalize across any domain. So that's what the term means. And continual learning. Read the options and tell what is the most logical. Second one, right? Like I don't want to forget what is learned. It's like I want to continuously update my model to incorporate new knowledge without forgetting old one. Like suppose I have 10 classes right now and I learn on them, then I don't have access to this. Then I have new classes. So I want to update my model using the new data, but because I don't have access to the old data, I still want to remember them, because it's like it becomes so first I have 10 classes, say now I have new 5 classes, then I want to do well over all the 15 classes without sacrificing much on the old 10 classes. So such task problem is called as continual learning. And k-short learning is
only few samples for some classes to learn.
So k-short means how many samples I have per class. It'll be, so there are several, there is zero shot learning, one shot learning, few shot learning, all such problems. Yeah, so here in question 8, what matches to what? What do you think? So this BIOL is a self-supervised learning method where they don't actually use any negative samples. So this is, so many self-supervised methods, so they actually train it such that nearby similar looking samples should be close in my feature space, and dissimilar looking images should be far away in my feature space. So basically, if you choose a sample, they'll pick a set of positive images, one or a few positive images, and a set of negative images, and the positive images should be close. So what is close, what is like far, like what falls into the set of similar images, dissimilar images. So these methods are called contrastive learning methods. But in BIOL, they don't actually use any negative samples. In universal adversarial attack, what does universal adversarial attack map to? It's a white box adversarial attack. So the universal adversarial attack is where they try to uh, learn one universal perturbation that can generate adversarial images for all the input images. It's not image specific. So this gradient estimation is used for black box adversarial attack. Gradient estimation is technically used in both, but
when it is used in both, why are you saying only black box? We can say white box also, no?
what?
I mean, gradient estimation can be used in black box and white box. Why are you only saying black box?
It can be used in both, yeah.
But the both the options should be true, no? Both the options should be true.
Both should
Second
be
and
true, yeah.
okay.
And this MOCO method actually uses a dictionary lookup method, but I have also not read that paper properly, so I don't know what exactly it means.
MOCO is. Ma'am, let's go to the numericals. Theory we will study. This question.
Apply a function-based adversarial attack on the given 4x4 image. The image and the additive perturbation are given below. Here the function is given as this. So in a function-based adversarial attack, so in general what we are trying to do is do some x plus some delta, right? Like I want to perturb it by some amount. In function-based adversarial attack, they don't operate directly on the image, but they try to do it as a function of this sample, like do some f of x plus delta. So like the perturbation is through a function. So they have given the function here, and so this is my x, this is gamma is my, so f of x plus gamma is the perturbation. So
F of x plus gamma.
yeah, so say at 1 comma 1, what the value is 20, right? X is 20. So what is f of x here?
21. 21.
How 21?
20 plus 1, f of x plus gamma.
0.1 into 20, 2.
2 plus
0.1 into 20.
yeah, 2. So f of x is 2, and so basically my perturbed
And how f of x is 2?
x is less than 100, so 0.1 into 20 is 2, right?
0.1 into 20. Take it.
0.1 into 20, and
20.
my f of x plus delta is 2 plus my delta is 1, is 3.
Delta. When delta man? It's gamma.
Fine, gamma, whatever. Yeah, that's all it is.
एक बार देखो शक्ल देख लीजिए मैम, एक बार और देख लो.
What?
एक बार वो देखो क्वेश्चन बस और अच्छे से. अच्छा, तो 160 जैसे 160 है, 160 ग्रेटर देन लेस देन 200, तो ये होगी 0.7 into 160 ना.
0.7 into 160 plus 2.
Okay, fine. Understood.
This question. So for the affine classifier, which is denoted by a linear function W transpose X plus B, weight is given, bias is given, the minimum perturbation required to change the class of an input. So that is, I have some x naught, I want to make it x naught plus delta. That will change my prediction actually. Like, say, suppose my if this represents the line W transpose X plus B equal to 0, so this is the classifier, right? And say x naught is somewhere here. So what is the perturbation I should add such that this changes? That means I want to go from say this belongs to 0 and this is class 1. This side of the line is class 1 and say this is class 0. Now I want to do something, add something to x naught to actually bring it this side. That is, I should add a so what should I do in order to, so how will the delta vector look like in this space? Suppose this is my origin, so this is my vector x naught, and now I want to add a delta that will take it to the other class. Visually, where should the say this is x prime, so where should x prime be? So I want to take this sample from here and I want to cross this, correct? Only then the classification will change. Like the minimum perturbation I am adding in order to change the class of my input. So here, as long as I am on this like this side of the line, it will always predict it as 0, class 0, right? Whatever the delta is, if I take this image from this place to this place, say if this is x prime, what will its prediction be? Still 0, right? Any of these directions, it will still be class 0, correct? But I want to add it, so basically go in this direction and like just cross this so that it starts predicting it as class 1. Yeah, so if x naught is this would be like my minimum delta in order to change the class. Does that make sense?
Yes, ma'am.
So how do you compute this vector? This
Ma'am,
is
I
from
think it is support vector machine, no?
No, this is nothing about support vector machine. I just want to take, I know I have access to this equation and I have this sample. I want to compute this delta. So you all agree this should be perpendicular to this. That's the least distance, right?
Yes.
I want to compute this delta. Like suppose, like think of it as solving this. If I it's like you have to use this. How do you compute distance between two parallel lines? Something like that. Use that formula and in what direction?
Distance between two parallel lines. Gradient is 0, ma'am, between two lines.
What?
Gradient is 0 between two parallel lines. Product of the gradients.
Gradient not. And see the this direction, what is this direction vector? Which are the line perpendicular to the line. This will be the direction of W, right? If this is the line W transpose X plus B equal to 0, the line perpendicular to that represents W, right? So I know the direction. So delta should be in the same direction as W. But now I need to identify the length of this vector delta. Direction I know, but it is some constant into that vector, right? So this constant, like what is the length of this vector delta? So that is actually the distance between these two parallel lines. So the distance between two parallel lines is given by what? Say if f of x is W transpose X plus B, and this point here, so this is my x prime, right? So this is my x prime, this is my x naught. So the so the length of delta is given by f of x prime minus f of x naught divided by norm of W. This is from geometry, okay? Not going to prove that. So here for f of x prime we know that so f of x prime is 0, right? Because it is on this line W transpose X plus B equal to 0. So this is actually equal to minus f of x naught divided by norm of W. So my vector delta is actually minus f. W into W. Now you have all of these, right? We know x naught and we know W, and you can compute delta.
Where is W?
W is given, no?
W is given. How to compute delta? A minus f of x naught.
What else is there? That's all, I think. This does not have any more numericals.
Ma'am. Hello?
Yeah.
Ma'am, let us solve this question. Okay, minus f of x not equal to minus. Let me see the question. Where is it? X is what? Minus f of x naught. W naught transpose x naught plus b naught. Minus f of x naught मतलब W transpose x naught plus b.
What?
Ma'am, f of x naught is W transpose x naught plus b, na?
Yeah.
Okay. And what is W, ma'am? Norm of W?
Norm of W is norm of length of the L2 norm.
Achha. So it is 3, I think, na? 1 to 3.
What? Norm of W is what? 1 plus 2 square plus 1.
Achha. 1 plus 2 square plus 1 square root of. Okay. And what is W?
Yeah, but if L2 norm will take as a square, so it will only 6.
Norm is square
L2
root.
norm is you will take the square.
It will be under root, no?
L2 norm is you will take the square, so.
No, you will square the inner
Okay.
elements, but the norm is square root of it.
And ma'am, this W vector,
Okay.
upper W vector, what is the value?
-1 to 1. So what it will be? So f of x naught is -1 into 1 plus 2 plus 1 only. 3 h2. So it is, so delta will be -2 divided by root 6 into 1 -1 2 and 1.
By root 6. It is -4 by root 6. Not -4.
What is 2 by root 6?
2 by root 6. So 2 by root 6 into 2 into root 6 by 6. Root 6 by 3.
As 0.81, right?
Answer is not correct.
It has to be 1 by 3. That means this has to be 6 only, then you'll get the answer. I think this is square. Norm square, is it? I don't remember it. Someone can check.
Norm square.
If it is norm square, you'll get the answer.
Okay, कोई बात नहीं. We'll look into it. Ma'am?
Be 2 by 6. Okay, which of these is not a self-supervised task, you think?
Ma'am, here leave the theories. Theories we will do, ma'am.
Tell no, last one. Next we'll go to.
Which one? अच्छा, self-supervised. क्या है? Predicting the rotation. Not as predicting the rotation तो ठीक है. Ma'am, I think generating an image.
Right.
Yeah, third.
Given a random noise.
Correct. So in self-supervision, I try to mask out a certain part of the input and try to predict it, or like create versions of it and try to predict what it means. Right? Okay then.
Let's come back. May I share it?
Yeah, you can
I'm
share.
Okay. Can you see, ma'am?
Yeah. What?
मैम
was-
ये जो क्वेश्चन है सेकंड वाला
This
क्वेश्चन ये
is
देखिए
which-
सिक्स्थ वाले क्वेश्चन
Which
Sixth.
week's? Last week's problems.
दिस इज नॉट लास्ट वीक दिस इज वीक 1 कुछ क्वेश्चंस है जो मुझे वीक 1
Week 1.
छोटे
Okay.
छोटे क्वेश्चन है मैम छोटे छोटे हो जाएंगे ये देखिए क्वेश्चन है छोटा सा प्यारा सा पर प्लीज रीड मैम व्हेन इज परफॉर्म
When we perform SVD on a 3x3 2D kernel, we obtain the following rectangular
डायग्राम
diagonal matrix at Is the 2D kernel
Separable.
separable?
Yeah, the hints also. A two-dimensional pedagogy is separable. It can be expressed. This one.
So if it can be expressed as the outer product of two vectors, so what is an outer product?
Outer product, suppose I am taking one row and one column, and if we are doing the product and if we are getting the same matrix, then we can say it is separable.
That is, so the matrix should be able to say I have two vectors x and y. That matrix should be able to, I should be able to write it as x into y transpose to get a matrix. That's what they mean as an outer product of two vectors. Here in this matrix they've given the what in SVD, so they have given the sigma of it, right? So what does the sigma contain actually? What does 30 and 10 imply?
Singular value, we can say.
Singular values of those, right? So there are so basically the matrix can be written as like you have two singular values and you will have corresponding eigenvectors of them also. So suppose so two vectors v1 and v2 corresponding to both of them, and if you write the singular value decomposition, so singular value decomposition, basically the matrix you are writing it as vd v transpose, something like that, right? Vd v transpose. If you expand that putting this sigma, you have two vectors v1 and v2, so basically it's like 30 into v1 v2 transpose plus 10 into v2 v2 transpose, right? So it has two independent components.
And if we do the product, if we get the same matrix, then it is separable, simple.
If it is separable only if it can be written as outer product of two products. That means it should be like a rank 1 matrix, like x into y transpose I should be able to write.
Okay, fine. Clear. एक और question ये देखिए. You can consider 4x4 image.
Where each pixel uses a
4-bit signed representation.
4-bit signed representation. Reverse the contrast of the following image. Okay.
C is the answer. Minus 4, 8, minus 1, 2, minus 1, 2, minus 3, minus 6. How it is reversing them?
Go up. So what is the range of it? Minus 2 cube. That is minus 8 to 7. Correct.
Maybe you have to create a map where you write down 8 and go to 7 to and then go down to minus 8 and then reverse the order, create a mapping, and then you can substitute the value.
What are you to do?
So if you have a pen, you can write it down.
Please tell me.
Write down 7, 6, 5, 4, 3, 2, 1, 0. Up to minus 8.
7, 6, 5, 4, 3, 2, 1, 0.
6 up to minus 8.
That's 6 to minus 8.
Right. And you map, is it 6 or 7? I'm sorry, it's 7.
7.
So 7.
0 to 7 and minus 8 to 7.
Yeah. And what you do is you invert the column that you have written. So now 7 will get mapped to minus.
The
6
7
will,
will map to minus 8.
6 will
6
get
to
mapped
minus
to 7. Yeah. So like this, you create a mapping and then replace the value.
5 to minus 6.
Is it matching?
Okay.
7 to minus 8, 6 to minus 7, and so on. It's like creating an inverse image. Black will become white, white will become black, something like that.
Correct.
Yeah, correct.
7 will be minus 8. 1 second. 7 will be minus. Someone get. 6 will be minus 7. 6. 6 will be minus 7. I think it's clear. Yes. Thank you.
What is the central element after applying linear contrast stretching? So, in linear contrast stretching, here also they've written 4-bit grayscale image, no? 4-bit grayscale image means, so what is the range it can take? I mean, pixel values range lies between 0 to 2 to the power 4 minus 1, right?
0 to 2 to the power 4 minus
0 to 15.
So 0 to 15 is its entire range. So, but in this image, so I have values only from 3, 4, 5, 6, 7, 8. So the range is only from 3 to 8. But I want to stretch this range of 3 to 8 to 0 to 15.
Okay.
So basically you have to do x minus minimum of the matrix by max of the matrix minus min of the matrix into
x into.
So you should stretch it such that 8 goes to 15 and 0 goes to 3.
Okay.
So that's your linear map.
What is the formula, ma'am? 0 goes to 3.
3 should go to 0 and 8 should go to 15.
Okay. Then, ma'am, 4 should go to, how will I do, ma'am? Formula है कोई?
You can consider it as 2 points, right?
Yeah.
You have x1, y1, x2, y2, and then you can create a line.
So you have two points to map, which you want to map, no? 3. So the 2 points are basically 3, 0 and 8, 15. So get the line for those 2 points and then substitute the other values you will get.
How many?
See, the equation of that line will be basically f of, so the current matrix minus minimum of that divided by max by min, max minus minimum.
Current matrix upon minimum of?
So minimum is 3 here, no?
Ma'am, tell me the formula. Current matrix upon minimum of?
X minus 3 divided by 8 minus 3 into 15.
X minus 3. X minus 3 by 5 into 15.
Into 15. Then round off to nearest integer. So do that.
X minus 3 upon 8 minus 3. X minus 3 upon 8 minus 3.
1 by 5 into 15, no? 3 you will get.
Now I'm going to put all the values. 4 minus 3 is 1. Ma'am? Manobra ma'am? What I am asking, that x minus 3 upon 8 minus 3 into 15. What you did actually? How you got this formula?
3 is minimum value, 8 is maximum value.
Okay.
That I
18
substituted.
अच्छा ये कौन सा फार्मूला है x minus x1 upon x2 minus ऐसे कुछ
That
फार्मूला
is the line equation to get the equation of line if you are given 2 points.
अच्छा y2 minus y1 upon x2 minus x1 इस तरह की फार्मूला है
Yeah.
ठीक है ये देख लो मैम नेक्स्ट क्वेश्चन एक देखिए मैप द फॉलोइंग ऑपरेशंस
Do the types provide your answer? Assume that the image has this. To their types. What is that? 0, 1 and 2 correspond to point, local and global operation. So mean of an image. What kind of an operation is mean? See, pointwise means at every location I am applying some function, treating every point individually. Local means so my output of the current point is actually a function of a local neighborhood. Global operation means my output is dependent on the entire image, something like that.
Okay.
So for mean of an image, mean is a function of what? Point wise function, or is it a local function or global function?
a global function
I need all the values, right, in the image. So it's a global operation. That's why
y2 मैम
it's a global operation, no?
अच्छा global means 2
There is written that, no?
Two is a
0
global
means
operation.
point, 1 means local, 2 is global.
okay it's convolution ये वाले next
Convolution with kernel of size 1 cross 1.
It's a local single point.
Single point, right? It is 1 cross 1 filter, means only on that point I am applying.
okay
So it's a point wise operation.
this one cross correlation
3 cross 3 means I am looking at a local neighborhood, right? Left pixel, right pixel, top, left, like small neighborhood of 3 cross 3.
and it's local
So it is a local operation.
Yeah, because 10 by 10 is a full image and 3 by 3 is a local.
3 local neighborhood.
flip and make by 180 degree
Flip
it's
an
global I
image
think
by
180 degree
It's just a global item.
it's not really global, no.
Flip images.
It's only point wise, no.
what is this ma'am flip and
Like,
image
not really. I mean, you need to see in flipping. I am not my image is not really function of its local or global neighborhood, but it maps to some other pixel. I think that's why they mean point wise. What is the answer?
So in flipping, we are not concerned
We are
with
not-
the values. We are concerned with the position.
We
Position,
are not changing the
exactly.
pixel. We are not changing the pixel
Yeah.
value.
Yeah.
Right.
So it's sort of a mapping between locations only, not doesn't bother about the values.
ma'am flipping means the locations are also changing na
It's only function of location, no.
Hmm.
See, left corner will map to the
right corner
right corner.
Yeah, but the distribution of pixels is not changing. They are the same
They're the
distribution.
same, yeah.
okay this one
Average filter given below. Consider the average filter given below and the correct normalizing factor for that is given by.
Add all the values.
why add all the values
Because we are going to do the averaging filter. We have to average, so 1 by 20 will be there.
okay
You should not shift your mean value of the image when you are doing averaging. So
okay add the clear
Yeah.
Then please tell about the final paper.
Hmm?
Please tell about the final exam. Something.
final exam.
Ma'am,
How the questions will be there, whether we have to do the assignments only, something.
It would be similar to these kind of questions only, I believe.
I have already appeared in the examination. Okay, these type of numerical questions will be there, and the theory match the following. These questions will be there.
These kind of
And
questions only, right?
up 40 questions are there.
All of them MCQs, right?
All the MCQs.
Or you have appeared for the same deep learning course or any other course?
I have appeared for all this paper also last year.
Okay.
Uh,
So how was
Okay.
your score at that time?
Score, I failed in the practicals, whatever these assignments, and I cleared in the exam, this one, theory, but it's of no use.
Okay. So the paper is somewhat easy than these assignments, or it will be difficult?
It's like this only. It's not difficult. If you can solve these questions, you can solve it.
Okay, thank you.
That's why I'm having these questions. Let's grab ma'am and sort out the questions.
Yeah, today is the last session, no? Last session.
No,
Ma'am, can you have the last year paper? Can you please share that with us?
He should have, no, you can share it with them right now.
Okay, I have it. I will share. Please take my email ID. Okay?
Yeah, please, sir. Can you please provide your email ID?
Swaroop, SWARUP, Swaroop.
Put it in the chat here, people.
Okay. First, let's do the questions. Let's do the questions, and then I'm going to put it in the chat. Okay?
The last time also I have told you that please
Okay.
share the
Okay,
previous year questions.
Okay, wait. Where is
You
that?
share it here only. If you can share it here, you can do it right away. Fine. People can.
This one is the email ID. Swaroop.gorai@gmail.com.
Won't it be better if you share it in the discussion forum? Is it possible?
It's possible, but I have already shared here also, na?
No,
Oh,
no,
not
he's
the-
asking the paper. Can you put the paper? there?
Okay. Paper in the discussion forum.
Right.
So once I tried to do it, it was not getting uploaded over there.
Okay. Maybe you could
You
add
can
it to a
put a
drive.
link of the file, like a drive link or something, and share it here.
Ma'am, it's not possible because that the file is with my mail ID. Okay, without my mail ID, they will get nothing.
Don't you have a PDF like this?
No, I don't have PDF like this. Let me see it. One second. Control C. Control V. See, this is the previous year. You cannot
They
check.
can't log in. They can't log in here.
Ma'am, leave it. Now let's come to this question. Which of the following is an example of high-pass filter?
Following what?
Second one, I guess.
Why?
I just remember that it's a zero surrounded by one.
Yeah, it was covered in the lecture also.
It was surrounded by one.
Yeah.
Okay.
I think it's called ideal high pass filter.
High-pass filter.
See, in high pass filter, you are trying to basically wait.
Ma'am, is it correct that zero surrounded by one? That is high-pass.
High pass filter, we are blocking the low frequency values,
Okay.
isn't it?
Go down.
Yes,
The last one is a high pass filter.
last one. Why, ma'am?
You are trying to find differences, no? So you are sort of this high pass filter, meaning you are trying to see if your bottom was diagonal. It's like see, basically it tries to detect diagonals in an image. So I'm trying to see how my right bottom corner is different from the left top corner, right? So it's like edge detection.
Okay.
So edge detection is high pass filter.
Okay, fine. Edge detection, edge detection.
So that specific filter actually will detect diagonals. Like if you have have an image with just white on the not like if so the upper left corner is say white pixels and the bottom one entire thing is black pixel, so it will detect the diagonal there, something like that.
Okay, it's like that. And this one, math of college using their corresponding Fourier transform.
Corresponding Fourier transform. Show options.
So to match actually.
4. Okay.
130. You want? What is the 3?
See, those lines you can tell because the first one has horizontal lines. So the along x direction, if I take gradients, it will be like 0 only. If I try to detect horizontal, yeah. The first one will match to 3, is it? 4.
Why? What? Yes, ma'am.
First one will match to 3. Third one will match to 2 if I'm not 1 if I'm not wrong.
Third which match to 1.
Third will match to 1. Then in this image, fourth and the other one.
Fourth to this one.
This.
Ma'am, is there any way, because this type of questions will come, how will it represent it using the same?
See, for the first one, it has only, if I along horizontal direction, there is no changes, right? Only vertically there is change. So along horizontally, my frequencies don't change. So that is why I will not have impulses on x direction. It will have only on y. Like.
Okay. Second one.
That's why the third one, because it has impulses only along in y direction. And in third one, it is the other way, right? Sort of.
Okay.
It has stripes vertically, so you will see impulses horizontally. That's why it will match to the first one. The second one will match to second only. I don't know, I'm guessing. I'm not very sure.
Ma'am, second to fourth.
Okay. Fourth to that.
In guessing we will fail, ma'am. Is there any way?
I think you can find out the answer just by first and third. Can you just like?
Yeah. Rule out. See, the second one and maybe both of them are like, it has lots of gradients along both x direction and y direction. So it can't be impulses, it will have frequencies everywhere, sort of. So that's why second and fourth will map to second and fourth. That much you can tell. More than that is not really easy.
Yeah, but in fourth, the frequencies are changing very abnormally.
Yeah.
But in second, the frequencies are changing in a slight uniform manner.
Correct. See, in second, there are specific edges only, right? Those boxes are there. So only along those edges you will have frequencies. So the directions in which I have frequencies are sort of fixed. That is why it will map to 4.
Yeah, and finally the fourth one, because there is a lot of changes
in all directions, so it will go to second.
Okay.
Means six. I have to do by elimination. This question, ma'am.
What? Consider the Harris corner detection algorithm where the hyperparameter k is this. The autocorrelation is given by. By the way, how does this exam? Is it a physical exam or online one?
Online.
Online. So it is open book, right?
No, it's not open.
Not
No, I think it is online,
It's
but
a
you have to go
physical
to
exam, but it's
center.
not. Yeah.
Online means you have to go to center. It's a computer-based exam, but we have to go to examination center. Maybe.
Oh, okay. So it is not open book.
Yeah, we cannot do it from our home. We have to go to the examination center.
Ma'am, with open book also will fail only because I cannot solve it without your help.
Open book. Open book means at least where you need formulas, you don't have to remember things.
This one, 7.
The autocorrelation is given by E is equal to U transpose XU, where X can be among the following. Find the X that gave a cornerness response greater than 10. So here X has the eigenvalues, no? See, U transpose XU is an eigenvalue decomposition of that autocorrelation matrix E. So basically X has the eigenvalues along its, what? Yeah. X can be one of the following. Not eigenvalues, it's the correlation matrix. So for this you can, the criteria to detect whether it is a corner or not is a function of trace and determinant of those matrices. It's lambda 1 plus lambda 2 whole square minus k into lambda 1 lambda 2 square, if I am not wrong.
Tell me, ma'am, what you said.
See, one thing is you have to identify the trace and determinant of these matrices, okay? So trace is sum of the diagonal elements, and determinant formula you know, A, B, C, D means AD minus BC is the determinant. So you can find the trace and determinant of these matrices. Then, so the criteria, the measure of cornerness is trace square minus k into determinant square. I think trace square minus k into determinant square. You should check that once. So if you for each of this matrix you can substitute k, trace and determinant and get the cornerness value. So for which of them you will get greater than 10, that is what that is the answer.
Okay. Trace means 7 plus 5, 12. Trace is the sum of diagonal elements, na?
Yeah. 7 plus 5, 12, and determinant is 12 minus 1, 11. So 12 minus 12 square, 12 square minus 0.15 into
34. Determinant is 34, na? First K.
Okay, whatever.
12 minus 15 to 34. 570, 85, 170, to the 340, 3.4. तो 12 minus 9 हो गया मैम. Greater than 10 बोला.
Check if trace or determinant, which one comes in what order, but it's something like that.
Okay, something like that. Okay, I will see. Such easy questions, ma'am, but I do not know the questions. See this one, the छोटा सा question.
See, it's a 3x3 neighborhood, and this you should be able. Anyone?
Anybody? Question number 10.
Yeah, starting with 10 only. The second element is x, y minus 1. Okay, y.
See, x minus 1 and y minus 1 means it is the topmost corner, no?
So
So its
10,
coefficient
20.
is 10 by 2.
Okay.
So the value should be 5.
10, 20, 0. Okay.
So we basically have to do a 10 divided by 0, 10
10
divided by
by
2,
2, 20 by 2, 30 by 2 and so on. And put them into the corresponding locations in the kernel. Like if you take the middle one only, here that is enough. Middle one and one some other. Like see, coefficient of f of xy is 30, 30 by 2. So middle element should be 15. So it is either 3 or 4. Take another value, and where do those two differ?
Yeah, it is.
You can take the left corner and see what will happen.
We can take the last value, which is minus 30.
Last value. That is x plus 1 and y plus 1. No? So the coefficient of
Yeah,
that
minus
is
60 by 2, minus 30, direct answer.
minus 60 by 2. So it is minus 30. That gives
Even
you
if we take any value, we'll finally reach the conclusion.
Yeah.
I mean, it's an easy question.
Yeah.
It's an easy question.
Coefficients, you should put it into a matrix, that's all.
Yeah, if you do from right side, we'll directly get the answer.
ठीक है समझ आ गया समझ आ गया. It's so easy. This one.
Given a 2 cross 2 matrix M, where M is the second moment matrix of which pixels that is obtained while applying the candidate detector, find the measure of straightness. Candidate detection measure of straightness. The last eigenvalue should be in the denominator. What is measure of straightness? I have forgotten Canyon's detector.
Friends, can you help? Tapas?
Yeah, Canyon detector, we need to find out Google.
Okay. 12th वाले question में 12th वाला देखिए.
What?
Point.
During the key point localization shift, we get the following Hessian matrix for a particular candidate point. Should this key point be rejected if the threshold A is 5? This is also like that Harris corner thing only, that it is, wait, what is the trace of this? Trace of this is 8 and determinant is 16 minus 4, 12.
Okay, 12.
12. It is lambda 1. I think that whatever function is yes, it is lambda 1 into lambda 2, but wait, it is determinant square determinant by trace square, I think, or the other way around. So if
Determinant by trace square or inverse.
Or the other way around, like
Inverse ulta
I think it's trace square by determinant.
trace square by determinant. Oh yeah, one of them. Yeah,
Determinant.
that's a measure, and if it is lesser than that, I think you'll reject. So the threshold
8
they have
minus-
given, you should compute that function and then see what it is.
2 by 3. 0.66. That is less than 5. वो भी रिजेक्ट कर दो, ऐसे ही है ना?
You can review those formulas once, what that measure is.
अच्छा,
Trace square by determinant or trace by something like that.
ट्रेस स्क्वायर बाय डिटरमिनेंट होगा।
I am not sure, you should check.
मैम एक छोटा क्वेश्चन है ये,
Local binary pattern descriptor computed anti-clockwise starting from bottom right for the following 3x3 image patch is.
So will be making binary pattern here, comparing the values by 100. Less than 100 will become 0, more than 100 will become 1.
less than 100 0.
Yeah, so if you start with
Compare with the center and
compare with the center, so for 20 it becomes 0, for 10 it becomes 0, for 200 it becomes 1, for 90 it becomes 0, for 150 becomes 0, 150 becomes 1, 50 becomes
0.
0, 150 becomes 1, and 201 becomes 1. That
then
pattern
starting
we have
from
to write.
200 you should write down that number.
0 1 1 0.
Okay, we have to start with 200. Okay, we
200
have to
they've
start with
written
200.
bottom right, no bottom right, no, so 150.
I was starting with top left actually.
Computed anti-clockwise starting from bottom right, so you should go from 150 50 150 201 in that order and write down that binary pattern.
How I'll write, man? 150 क्या लिखूं? 1.
So 150, like first you write 1 and zeros, no, then go in anti-clockwise direction and write down that binary numbers.
That greater than 100 is 1 ना?
Yes.
Yeah,
तो 150 उसके ऊपर गए तो 0, फिर 150 1 हो गए,
so it will be like 1 0 1 1 0 0 1
और 100 का क्या लिखूं?
0
1 या 0?
Cross.
हाँ?
Center pixel will be cross.
Cross.
You don't have to write anything.
Okay. So it will be 0 1 1.
No, it will be 1 0 1 1 0 0 1 0.
you should start from 150 right, bottom right corner, and then go anti-clockwise.
Yeah.
1 0 1 1 0. Ma'am, can I say?
He wrote the answer, no, he put it
In the chat.
Okay, chat. Chat. Okay, what is that? 1 0 1 1 0 0 1 0. ठीक है, ये हो गया। फिर क्या करेंगे इसको?
Convert into decimal.
Okay. Then okay, understood. Now it's clear. Okay. Then convert to decimal. ठीक है. This one then?
consider the graph of gradient magnitudes for different curves. Identify whether these curves are edges or not using hysteresis thresholding. Mark the curve as 1 if it's an edge pixel, otherwise mark it as 0. This is what is there in canny edge detection hysteresis. So they set 2 thresholds on so if the gradient magnitude is more than the higher threshold, then you confidently mark it as an edge pixel. If it is lesser than the lower threshold, you say it's not an edge pixel. If it is in between, then they do the next step. What is that? Something they do to extend your edges. I forgot. So for C, it will be an edge pixel.
Why then?
Because gradient magnitude is more than higher threshold.
So for D it will be 0.
For A and E, it will be 0. Go down. What are the options?
Answer. For A is 0.
Everything.
D is 0.
Only for D, it is 1.
C is 1. D is 1. C and D is 1.
C and
C and D is 1.
C and D. because D.
Yeah, C is above threshold. High.
अच्छा ये सारा तो वो भी है ये हाई को टच कर रहा है इसीलिए क्या
I think as I remember, sir has told that if someone is going from low to high, it's going to cross. Then also we have to consider that. So D is crossing high. It starts from in between low and high, and it's going to cross. So that's why it's taken as 1.
Okay, okay.
As I
Fine,
remember.
fine. Fine. This one, man.
Go up. During the orientation assignment step in 6th, we obtain an image after convolving it with a question.
Positive. The appropriate sigma value.
From that image, the magnitude m and the orientation theta for the paths are A and B respectively. The magnitude and orientation of this patch. You should get the horizontal, I mean the gradient. You should compute gradients along x direction, y direction, and then get the magnitude and orientation from that. Like you should apply that Sobel filter.
Sobel filter.
Edge filter, horizontal edge filter, vertical edge filter you should apply.
Edge filter means 0 at the middle and 1 on all surrounding it. No? That is edge.
Like on the zeros in the middle, ones on the right, minus ones on the left, and similarly zeros along horizontal, like below one says +1, above one says -1. So using that you will get two, one is horizontal gradient, vertical gradient you will get. So for theta you should take tan inverse of vertical gradient by horizontal gradient. For magnitude you should do square root of horizontal gradient square plus vertical gradient square.
Are you sure, ma'am? This is the formula.
That only. Then you will get both A and B.
Okay. Thank you, ma'am. This I will do. Can you see this figure?
Yeah. Consider the two images A and B below. In A dog is present on the left part of the image, and in B, the same dog appears on the right part of the image. These two images have bag-of-words representation because bag-of-words representation.
Yeah, so here bag of words I understand is it preserves the look objects or words. It does not preserve where these words are, which just the keyword storage kind of thing. So here we have object like a dog. So the object is the same dog. Only thing is it is here and there in the different side.
Okay. So does not preserve special information, that means.
Whoever does not preserve where it is on left or right, but it preserves what is there in that.
Okay, fine, clear, ma'am, clear.
It sort of will have a vocabulary and
Yes.
so in both cases, like it will map to the same object in the vocabulary because it has the same object. I mean,
Okay.
something like that.
And this one, in ransack,
What is the probability that the algorithm never selects a whole set of
20.
inlayers from 20 data points which has 5 inlayers
Fine.
in total for k is equal to 2 tests. 2 time steps here. N is equal to 2 is the minimum number of samples to fit a model. This is forgotten ransack. Probably never selects a whole set of inlayers from 20 data. Is the minimum number of for 2 time steps. This is what? It's a combinatorics problem.
and this is not properly combinatorial problem.
It is n is equal to 2, the minimum number of samples to fit a model. Like, so we are asking n is equal to, it can, how many samples are selected? So it is basically 1 minus the probability that it selects a whole set of inlayers. So the probability that it selects a whole set of inlayers is 1 minus what? Totally there are 20 data points. So from 20 data points, if I have to select 2 samples to fit a model, that will be 1 minus 5C2 by 20C2.
1 minus 5C2
by 20C2.
Okay.
So this whole thing should happen for 2 time steps. So this whole probability is square. If I am not wrong, I am not sure.
Somebody has written. Is the formula correct then?
I found it on the internet.
This formula.
But it's the ransack algorithm. So W is the ratio of inlayers. I'm sorry. What will be that? So 5 divided by 20.
5. Okay.
I'm asking. So if you have a look at the formula, we have N and K. What we need is W. So W is the ratio of inlayers. So in this particular question, what is that? Is it 5 divided by 20?
5 divided by 20, yeah.
Okay.
1 by 4.
5 divided by 20 and N is what? The number of samples. Number of samples.
1 by 4 raised to 2. So 1 by 16. So 1 minus 1 by 16. That's 15 by 16. 15 by 16 raised to 2. And what the answer will get? That 1 minus that.
1 minus 1 by 4 into, how you got 1 by 4 once more?
What is
Answer is not coming in that way.
Oh, is it?
15 by 16?
I think it is coming. So what you have to do is you don't have to do that 1 minus. So I'll send you the formula.
Send it.
1 second. Yeah. So we have to find the algorithm never selects the whole set of inliers. So that's 1 minus the probability of selecting whole set of inliers, right?
5 by 20.
Yeah, but I think there are two time steps also involved.
So that is K.
2 times, one after another one.
Actually, it is square, not whole square. Madam बोल रही थी, monogram है.
Two time steps, but I mean, I want this to happen twice, right? So for the second event also, the probability is same.
So is it possible first when k is equal to 1 probability something and when k is equal to 2 probability changes?
Obviously, that's why the answer is 0. Otherwise, it will be the square of something. No?
Yeah.
That will be different. Suppose 1 is 0.29, 1 will be 0.03. Second is 0.87, 0.87 is like that.
But
Monogram, these
oh,
type of
5
questions are
by 20. Okay. See, it's like I said 5C2 by
2 upon
that
26.
because I thought it is without replacement. Here, same sample can be selected again. So the probability of selecting an outlier is 5 by 20 once, and
1 will be 4 by 19.
what?
4 by
No,
19.
like, see that formula comes up because it is the probability that I don't select one outlier is 1 minus 5 by 20. I mean, what?
Okay.
1
I'm not
minus, not
selecting.
like I don't select two outliers is 1 minus 5 by 20 square.
नहीं मैम गलत. 1 minus 5 by 20 into
5 by 20 square because two samples I am trying to sample.
जब एक निकाल दिया आपने.
No, that formula is correct only. Like
It's 5 square by 20 square.
1 minus 5 by 20 square whole to the power square 2.
Square upon. Amit, please mute yourself. Amit, please mute.
It is 15 by 16 square. You will get 0.87.
Huh? 15 by
You are wait.
9 by 16.
W is 5 by 20. N is equal to 2. K is equal to 2. You will get substitute.
Equal to 2. ठीक है मैं भी देखूंगा मैं. एक क्वेश्चन ना.
You are making me write the whole exam.
नहीं मैम और 15 मिनट छोड़ दो. Then I will leave.
Swaroop,
हाँ.
We have only covered like 30-40% of it. If possible, if ma'am is free, maybe next week we could have another session.
So ask ma'am. First ask ma'am.
That's what I'm asking, ma'am.
When is your exam actually?
We have it on 30th, right?
30th, yeah. We need it beforehand, ma'am. We need it in 8/17, 18, like that, because we have to prepare. No?
30th.
Uh,
30th, you still have 2 weeks, no?
no, ma'am. 2 weeks, not ma'am. Yeah, I have 4 papers. I think it is only 2 days. 3.
Yeah.
Please,
I
ma'am.
have 3 papers.
I have 4.
Same
Oh my
here, ma'am.
god.
3.
So many courses, how are you managing to do?
Manogana ma'am. Actually, this semester I had 6 papers. One was scalable data science. It was a very tough paper. I had that, but paper was good. But in the discussion section, I have written that I was totally disappointed with the question paper. It was so easy. I need tough, but I should know the things. Na? I have disturbed professors in that paper also a lot, and I got such easy questions. I was so disappointed with the paper.
In this, I'm sure they'll not disappoint you.
मैम तो मैम आप कब देंगे? अगले फ्राइडे दे दीजिए क्लास.
What?
Next Friday.
Next Friday? Fine, we can meet.
Please, ma'am,
Officially
it's
it
a
ends
request.
today, but that's fine. I can meet.
No, it won't end, ma'am. Please promise.
What?
Please promise, ma'am, that next Friday you're taking the class.
Next Friday, this same time.
Same time, 6 to 7
Okay, fine.
or 6 to 7:30.
Fine,
Please,
fine.
ma'am, it's a request, huh?
Fine, I'll join.
Ma'am, in the problem solving session, that survey, I have written your name. That Manogana ma'am is superb, terrific, because she answers the questions. She never disappoints. Whatever, but you are friendly and you say that, okay, this I do not remember, and we are happy with it. You are not giving any wrong advice, and we are happy with that.
Okay, thank you.
Well, we are not here to check the knowledge. We are here to understand. We are understood, ma'am. That's the thing.
Yeah,
We
I
should do
also
it.
have read things along with you guys only. Most of it. Or
So,
I do
yeah,
the review,
next.
so I don't remember things. Usually.
Thank you, ma'am. Next Friday, pakka, ma'am.
Fine. I'll join the meeting next Friday also.
Okay. So, ma'am, please upload this session today only. This session and yesterday,
Yeah,
last week's session also.
Fine, I'll upload all of them today only.
Please, ma'am, it's a request. Please upload it, huh?
Yes, sure.
Okay. Thank you. Thanks a lot.
Thank you, ma'am.
Thanks a lot.
Thank you everyone.
Thank you, ma'am.
Thank you.
Thanks for your.
Okay, thank you.
Thank you, man.
Thank you.
See you.
See you next week then. I'll join.
Take care, ma'am.
Bye.
Bye.